In this video, we're going to look at an example of direct variation, a linear table, and a non-linear table. Our job is to determine what kind of information are we looking at, and then write the equation based on type of function. This video is also going to work on reading mathematics. So let's start with our first table. We didn't know whether it went through the origin. We didn't know there was a point at 2, 14, 5, 35, 7, 49, and 11, 77. And our job was to determine, is this a direct variation, a linear, or a not linear problem? As you can see, what we want to do is do the slope formula, y2 minus y1, a change in y, over x2 minus x1, a change in x. You're simply taking your points, so I have a point at 214, another point at 535, and calling this first set of points x1 and y1. So x1 is 2, y1 is 14, x2 is 5, y2 is 35. And you're simply plugging those numbers in place of my y2, y1, x2, x1. The reason we call them x1, y1 is really just the first x and y and second x and y. If I just called them x and y, I wouldn't know which one's which. So that's why we call them first x and y, second x and y. We see here, then we get 35 minus 14, that equals 21 on the top. On the bottom, my change in x is 5 minus 2, that's 3. 21 divided by 3 is 7. Remember, you want to take your change in y over your change in x. Notice that 35 and 5 are together, so they should be lined up over each other as well when we start that. Doing a similar idea for 535 and 749 on the second one, take 49 minus 35 over 7 minus 5. That gives me 14 over 2, which is 7. And a similar answer when I do 749 and 1177, that also will give me 7 as a slope. Because all of them have the same slope, this is a slope of 7. Now my idea here is it's definitely linear. Is it a direct variation? I know it's not linear because it has the same slope on all of them, so it has to be linear. Again, they all reduce to the same number, so it's definitely linear, but possibly a direct variation. Can't be a direct variation without being linear. So if it is linear, then it's could be a direct variation. But if it's not linear, it's definitely not a direct variation, as direct variations are a special type of linear. So one of the ways we can tell whether it's a direct variation is if it's proportional. Remember, it's proportional if I can take y divided by x and get the slope every time. Taking the 14 divided by 2 gives me 7. 35 divided by 5 is 7. 49 over 7 is 7. 77 over 11 is 7. So at this point, I know this is a direct variation, which means I also know then it has to go through the origin. So this has to be at 0, 0 for the y-intercept. I can also verify that using the point 2, 14. I could pick any point. I could pick 5 and 35, 7 and 49, 11 and 77. Doesn't matter. What I'm going to do is plug in those points in for y, m, x, and then I'm going to solve for b. I already know the slope is 7, that's m. So I put that in place of m in front of the x. We're using x is 2, so I put that in place of the x. And 14 is my y, so I put that in place of the y. And now I'm just solving an algebra problem for b, the y-intercept. 7 times 7 is 14. Subtract 14 from both sides, we see b is 0. So we write the equation y equals 7x. It's really y equals 7x plus 0, but we don't write the plus 0, it's just extra. So because its slope is a constant, meaning all the same, we know it's linear. Because it's proportional, meaning the dependent divided by the independent, in this case y divided by x, is in the slope for all of them, and my y-intercept goes through the origin at 0, 0, it's definitely a direct variation. All direct variations are proportional and have a y-intercept at 0, 0. On table B, we have linear, and we'll show you why that's true here. Notice my problem is different here. I don't know the y-intercept, but I do know there's a point at 217, 538, 752, and 1180. Again, doing the slope formula just like we did before, I have 217, 5, 38. I take the 38 minus the 17, that's second y minus the first y. That answer is 21. 5 minus 2 on the x part on the bottom is 3, that's 7. Looking at 538 and 752, this also gives me 52 minus 38 is 14, 7 minus 5 is 2, so it's 7 again. And between 752 and 1180 is still a slope of 7. 80 minus 52 is 28, 11 minus 7 is 4, and 28 divided by 4 is 7. So again, my slope here is 7. Notice these numbers are different though. So at this point, we know it's definitely linear, possibly a direct variation, because it has a constant slope, same thing all the time. They all reduce to the same number. So notice 21 over 3, I have to get that answer of 7. If I look at 14 over 2 and leave it, I don't realize all these are actually 7 unless I divide the top by bottom. Now we can check whether it's a direct variation by looking at the ratio y over x. It should be constant to be a direct variation. Or we could just find the y-intercept as it goes through and see if it goes through the origin. I suggest finding the y-intercept since you have to write the equation anyways, but I am going to show you the proportional idea just to show you why this isn't. If I take 17 divided by 2, right, the y divided by x, that's 8.5. 38 divided by 5 is 7.6. Already I can tell these are not the same. I don't really have to do the rest of them. And so I already know it's not a direct variation, which means it doesn't go through the origin 0, 0. Again, the reason I like to know if it's a direct variation, that's a shortcut. I don't have to do that extra math. In general, you can always do the slope formula, the y2 minus y1 or x2 minus x1, to get your slope between any 2 points. The y over x only works to get the slope when it's a direct variation. So, like we were saying, since we have to find the y-intercept anyways, let's find the y-intercept. Again, I can pick any 2 points, the 217, the 538, the 752, or the 1180, and plug it into the equation y equals mx plus b. We already found m. M is the slope. Slope is 7. So I want to put that 7 in place of m. X is 2 and y is 17, so it's 17 equals 7 times 2 plus b. 7 times 2 is 14, so I have 17 equals 14 plus b. We subtract 14 from both sides, we see b is 3. So my y-intercept's at 0, 3. Notice that's true no matter which problems or which points you would have picked. 7 is my slope, 5 is my x, 38 was my y. 38 equals 7 times 5 plus b. 7 times 5 is 35. I subtract 35 from both sides. 38 minus 35 is 3. And that was true whether you use the 752 or the 1180. You still got a y-intercept of 3. That's because it's all the same points from the same line, so it has to go through the same y-intercept. So at this point, because it's not through the origin, right, y-intercept does not go through 0, 0. It's only linear, not a direct variation, or it's not proportional. So my equation is y equals 7x plus 3. The 7 is the slope, that's the number in front of x. Y-intercepts that number by itself. Since it's positive 3, I write plus 3. If it was a negative 4, I would write 7x minus 4. And now that I have my equation, I can answer any questions about this, finding any other x or y value. On this problem, we have 214, 538, 750, 1182. Doing the slope formula just like before, 38 minus 14 over 5 minus 2, 24 over 3 is 8. Between 538 and 750, we have 50 minus 38 is 12. 7 minus 5 is 2. This is 6. I see 8 and 6. At this point, I could have stopped right here. I already know that this is not linear. These two numbers are not the same because the slope's not constant. This is not linear. And if it's not linear, it cannot be a direct variation, as a direct variation is a special type of linear. So at this point, it's not linear. At the moment, we're just going to stop. I don't have a way to find other types of functions, but that is something you'll learn how to do, is figure out what would this equation be and what would the point at 0 be. but that's for a different time.